Hey everybody, welcome back. And today what we're going to do is talk about some basic terms in chemistry. And so what I want to do first is sort of define what matter is and talk about what atoms are and what molecules are. And that's covered in section 1.1 of your book. And then we want to start out by sort of describing the 3 or 4 states that matter can occupy, which is something you need to know, and that's covered in section 1.2 of your book. Okay, and the next time we'll talk about how to classify matter by composition. Okay, so what is matter? So you may know already that matter is anything that has mass and occupies space. So needless to say, just about anything you can touch or feel is going to be matter. So if, for example, if I had a brick in my hand, it would occupy space. It has a certain amount of space and it has mass to it, and so that would be matter. So again, anything that you can sort of touch or feel, is clearly going to be matter. But there are some things out there that are a little bit more difficult to feel or see, but are still matter. So for example, air. Now, can you think of a simple experiment that you can do to show that air is matter? Well, one thing you could do, for example, is you could take an empty balloon and then you can put it on a balance and weigh it, and you'll get a certain weight. Then what you can do is blow up the balloon, and when you blow it up, you'll see that air in there that came from your lungs, the air in the balloon is occupying space. And what should happen is if you put the balloon on the balance, then that weight should be a little bit more, and it's due to the air inside of the balloon. So things like air are considered to be matter as well. Okay, so what are atoms? So atoms are the smallest particles that are found in matter that still carry the properties of the bulk matter. So let me sort of explain this with an example. Let's say you were lucky enough to find a gold nugget. And let's say you were feeling generous and you wanted to pass out pieces of the gold nugget to your fellow classmates. And so what you might do is use a simple physical means to break the gold nugget. Maybe you had a hammer or a sledgehammer or something really solid to break up the gold nugget. And so you were to break it up into pieces. And so you know at that point that the pieces of the gold that you have exactly the same properties as the big chunk of gold you had before it. So those pieces will have the same density as the big piece before for gold. And other reactive chemical properties will be maintained in those pieces. But you can break up those gold pieces even further. Maybe you want to give gold out to strangers. And you can continue to break up the gold into smaller and smaller and smaller pieces. But you'll get to a point where you've broken up the gold so far that you're down to a small piece that has properties of gold. But if you were to break up that piece further, it would completely lose gold's properties. That final piece that still retains gold's properties is the atom. Now, is it possible to break the atom, like for gold, further into little pieces such that those little pieces no longer have the property of gold? Yes, and that can be done in a lab. What you can do is reduce the pressure on the gold and the atoms, or the gold atoms, and you can have a lot of electricity passing through the gold. And under those conditions, you can get gold's electrons to fly off the nuclei of gold. And then what you have left, the gold nuclei, there may be just a few electrons left, not all that were there before, then that gold would no longer be gold. It would have properties of something else. Okay. And so I kind of described that there, what I just said. So let's talk a little bit about what molecules are. So molecules are 2 or more atoms joined by strong forces or chemical bonds in a specific geometric arrangement. So if you sort of look in the middle of that picture, you can sort of see pictures of water molecules. And one thing you'll notice is that they are molecules because you don't see one atom in that individual water molecule. You see 3 atoms bound together. Furthermore, they're in a specific geometric arrangement. One thing you might notice is that those hydrogen atoms, the white atoms, are not on the opposite side of the red oxygen atom. In fact, they're at a specific angle to each other compared to the red oxygen atom. And that angle is maintained with all water molecules. And so all those water molecules have a atomic arrangement that's quite specific. And so you can see the next molecule over, carbon dioxide, it is a molecule again because you don't see just one atom. You have 3 atoms bound together, but here it's a different geometric arrangement where the oxygen atoms are on the opposite side of the carbon. Glucose is next. It's a fairly large molecule that has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. But then if you go to the left side of that picture there, you can see hydrogen and oxygen. So they are both gases at room temperature. And importantly, neither of them are single atoms separated from one another. What they are atoms, 2 atoms apiece, stuck together into a molecule. And so these are diatomic molecules. And so they are molecules as well. And we have some other examples there, phosphorus and sulfur. Okay, so at this point, what we want to try to start doing is classifying matter if possible. And so one of the simplest ways to classify matter is by state. And you already know something about that. So you know probably at this point that matter can be in 3 states. It can be in the solid state, the liquid state, or the gaseous state. And there's actually a 4th state called the plasma state, which I'll talk a little bit about later. Another word for state is phase. And so they typically are used interchangeably, and I might do that as well. Okay, so one nice thing about classifying objects is because if you find, for example, a group of objects has characteristic properties, then if you have another object that is similar to that group, say in terms of a state, then you can predict that that other object will have those properties as well. So it's good to sort of classify matter. Okay, so one question we can sort of start out with is which of the following statements do you think is a good characteristic of the solid state? So do you think A, is it true that the solid state has a definite shape and a definite volume? Or maybe B, does a solid state have an indefinite shape and a definite volume? Or is it C, is that solid state has an indefinite shape and indefinite volume? So I'll let you think about that for a moment. You can pause the video and think about it, and you can restart. And so we'll start up again. And I'm hoping you will have guessed A. And so let's talk about maybe why the solid state really truly does have a definite shape and definite volume. What is it about the molecules in the solid state that causes these definite properties? So here we have a diagram of the 3 states of matter. And so we have on the left the solid state, in the middle the liquid state, and at the very end we have the gaseous state. So let's take a look at what is going on at the molecular level, because that may explain the properties of each of these states. So with the solid state, what you can see is that the molecules, sort of shown as green marbles if you will, the molecules are all packed together in an ordered array. And importantly, those molecules cannot move past each other in the solid state. Now that does not mean that the molecules in the solid state are not moving around. They actually have some energy at room temperature, and so they'll be vibrating in place back and forth. But that's it. They will not tend to move past each other. And so the fact that the molecules in the solid state are stuck where they are causes a solid to have a definite shape that cannot change and a definite volume that cannot change. So there are 2 kinds of forms of solids. One kind is called an amorphous form. Another kind is called a crystalline form. You don't need to know too much about that right now, but in chemistry, the form that we study the most will be the crystalline form. And crystalline forms of solids are where the atoms are sort of arranged in a very ordered arrangement. Now, occasionally you'll have a solid where that is not the case, where the atoms are not arranged in any kind of order. They're not too far apart from each other, but they're kind of in a disordered arrangement. And we're not going to talk about that too much, but you should know that. Okay. And then also, very importantly, because the atoms in the solid are very close together, you cannot press them further together. And so they are in a very condensed state. If that is the case, then the solid is said to be incompressible. Okay, so let's now talk about the liquid state. It's very similar to the solid state in terms of the molecules in one respect, in that in the liquid state, the molecules are touching each other like they are in the solid state. They're very close together, they're touching one another, but the difference is, while in the solid state, the molecules are in fixed positions and cannot move past each other, the molecules in the liquid state are not in fixed positions and they can move past each other. And so that trait allows liquid to have its properties that it does. And so one property that liquids have is that you know that although it has a definite volume, it does not have a definite shape. So let me explain that a little bit. So let's say you have a liquid like Coca-Cola, okay, and let's say you have 6 ounces of it, 6 ounces of volume, and you pour that into a cylindrical glass, okay, and so you have Coca-Cola about your drink. And let's say you're just an interested chemist and you want to see what happens when you pour the liquid Coca-Cola not into a cylindrical glass but a square glass. And what you'll notice is that if you have the Coca-Cola in the square glass, you still have the same volume, you have 6 ounces of it, but it has changed shape. And the reason why it has is because of the properties of the molecules and that they can kind of go past each other. Another thing that's important to know about a liquid, again, because the molecules are very close together, it is considered to be in a very condensed state. Therefore, liquids are also considered to be very incompressible. It is very difficult to apply pressure onto a liquid and to make it a smaller volume. Okay, and so another state of matter is the gaseous state. And so here, this is a significantly different state than the solids and the liquids. So with the solids and the liquids, the molecules were relatively close together, but now you can see that the molecules are not touching each other in that diagram. In fact, they are actually very far apart. If I had a gas molecule that was the size of a marble, maybe the next gas molecule might be, say, several rooms down. So the gas molecules are very far apart. Also, gases occur at higher temperatures than liquids and solids. They tend to have a lot of energy, and so they're moving around in space. And so most of the times, the gas molecules are moving past each other, but they can smack into one another, and those collisions will cause them to bounce off each other. So one thing to know is, because of these properties, that because the gas molecules are so far apart from one another, they do not have a definite shape or a definite volume. Now, one thing to know though, so it's very compressible. So the reason why it is compressible is because, unlike solids and liquids, which the molecules are close together and you can't push them in any further, the gas molecules are far apart and there's a lot of empty space between them. So it is possible to apply pressure on the gas and compress it further in. Now, one other state or phase of matter, which I'm not going to talk a lot about, but I should make mention of, is the plasma state. So in the plasma state, what happens is you might have gas molecules that get to a very high temperature, say to a temperature found in the interior of the sun. The temperature is so high that electrons tend to be stripped off the atoms. And when that happens, when electrons leave the atoms, because electrons are negatively charged, the atom that is left is now positively charged. And when you have a positively charged atom, that is an example of an ion. So in the plasma state, pretty much it's an extremely hot gas, such that what you really have is no longer whole atoms, but electrons stripped off, leaving just positive ions. So just be aware that that state also exists. Thank you for listening.